In this fourth video, we're going to be looking at bands. No, not that kind of band, but voltage bands in cable installations and the requirements for separation. And this video is one in a series of videos that we have made as part of a free CPD training package, which you can complete and get a certificate to prove you've completed the course. So what are Band 1 and Band 2 cables, and where do we tend to find them? Band 1 installations cover circuits like telecommunications, alarm systems, extra low voltage and data systems. Extra low voltage is a voltage range not exceeding 50 volts alternating current or 120 volts ripple-free direct current. Band 2 installations are voltage levels which tend to be used for residential, commercial and most industrial setups, including circuits for power and lighting, and operate at low voltage, with low voltage being categorised as a voltage more than 50 volts AC and 120 volts DC, but does not exceed 1000 volts AC and 1500 volts DC. The description of Band 1 and Band 2 can be found in definitions of BS 76711 and in the on-site guide, section 7.4.1. This part of the on-site guide goes into a little bit of detail with segregation, but we're going to use BS 7671 to explore further our understanding. We are starting at regulation 528. Proximity of wiring systems to other services. 528.1 says, except where one of the following methods is adopted, neither a voltage band 1 nor a voltage band 2 circuit shall be contained in the same wiring system as a circuit of nominal voltage exceeding that of low voltage. And a band 1 circuit shall not be contained in the same wiring system as a band 2 circuit. So it says quite definitively there that a band 1 and band 2 cable cannot be contained together in the same wiring system. So how can this be a thing then? It's a wiring system and it has them together. Oh, there's some indents. Let's read on. 1. Every cable or conductor is insulated for the highest voltage present. 2. Each conductor of a multi-core cable is insulated for the highest voltage present in the cable. We will be coming back to this one a bit later on. 3. The cables are insulated for their system voltage and installed in a separate compartment of a cable ducting or cable system. So that explains the dado trunking. Okay, the last 3 indents are 4. The cables are installed on a cable tray system where physical separation is provided by a partition. 5. A separate conduit, trunking or ducting system is employed. 6. For a multi-core cable, the cores of the band 1 circuit are separated from the cores of the band 2 circuit by an earthed metal screen of equivalent current carrying capacity to the largest core of the band 2 circuit. So why can't we combine band 1 cables with band 2? Well, it brings us back to a couple of things which happen when you push current through a cable. It heats up and it creates a magnetic field. The higher voltage of the band 2 will create a larger magnetic field than the band 1, as we can see here. If we bring these conductors next to each other, we can see that the electromagnetic field from the higher voltage cable could interfere with the extra low voltage cable. This creates interference in the band 1 cable, and if it was a communication cable, we could, well, lose communication. So to avoid this interference, we need to separate the band 1 and band 2 cables. This could be just by moving the cables further apart, but this is not always possible or practical. Certainly in offices where data connections for internet and power are required to the same positions. Dado trunking, like the one here, offers separation between band 1 and band 2 cables. We can use barriers, dividers, well, anything that will provide adequate separation. This is the same for cable tray or basket, and you tend to find on larger commercial or industrial jobs that the band 1 runs in separate containment like basket and band 2 in tray. Just a quick note though, for those who install containment for band 1 and band 2 systems, there is a regulation on the distance required between the containment. Certainly if the band 1 cable is telecommunication, you will need to refer to BS 6701, which is referenced in BS 7671 110.1.3. Clause 5.4.4.2 of BS 6701 states that a minimum separation of at least 50 mm between the telecommunication cables and power cables is required, even if it is in a different containment. But if you ran baskets side by side with 50 mm between the cables, this would not be sufficient, as basket is not a suitable barrier for the higher voltages present. So it will not give separation. This means you would need to either use a suitable barrier or keep a distance of 150 mm between the basket. Let's have another look at our drawing from earlier. So by me inserting a barrier here, the magnetic field generated from the band 2 cable is deflected and absorbed by the material.
And if we insert a metal divider, the electromagnetic field is dissipated and discharged safely away, hopefully to Earth as long as it's been bonded. So how can this EV Ultra cable from Doncaster Cables, which incorporates a band 1 and band 2 in the same cable, be able to offer separation? But there's actually two reasons why this cable is okay. First, both band 1 and band 2 are rated to the same nominal voltage. What that means is separation is not required because they could both carry the same voltage, which brings us back to the regulation from earlier. Each conductor of a multi-core cable is insulated for the highest voltage present in the cable. Okay, so this might seem like a bit of a regulatory loophole that's being exploited, because we know that the data cable will not be carrying the same voltage as the power cable, and the cables are still in close proximity to each other. And the regulation is clear, they shouldn't be. So how have they got around this? Well, we can see that the data cable is screened with this aluminium wrapper. This acts like the metallic barrier that we saw earlier in my drawing. But there is also this conductor here, what Doncaster Cable calls the lay length. This is here to further reduce interference, and even more so if it was connected to bonding. But it's not just Doncaster Cables who is saying their cable is okay combining band 1 and band 2. It is third-party tested by the British Approval Service for Cable, or BASEC. BASEC are an independent cable testing and certification company who put even the most robust cables through their paces. And if the cable passes and receives the BASEC badge of approval, you know this cable is of the highest quality. In their laboratories, they have put the EV Ultra cable through its paces and have accredited this cable, saying it achieves excellent data transmission without interference. So although this cable is BASEC approved and a great solution if you are running power and data to a wiring accessory, it doesn't have a British standard number like PVC flat twin and earth cable. So why can we still use it? Well, I'll be answering that question and more in the next and final video on cables, made in association with Doncaster Cables. And don't forget, you can view these as part of a free online training package to help you with your CPD and receive a certificate to prove you've completed the course. But until next time, it's bye-bye for now.